In part 2, we are going to continue with the example from my first lecture. We were looking to see if there was a significant correlation between homework hours per week and GPA. Here is the SPSS file for this correlation example. You can find this on Blackboard. It's listed. It's included under additional resources, so you can pull up this file also and practice with this file after you watch the lecture. So, for instance, if we have our researcher collected, recorded 2 different values for each student per week. So notice here are our students right here, and this researcher collected 2 values. Their total number of hours they spent on their homework, as reported by the student's parent, and the GPA for that week based on a multi-subject test given on a Friday afternoon. So, for a correlation, now remember that there are certain parametric assumptions that we need to meet if we're wanting to use a Pearson R. From Chapter 7, reading in your book, remember we have our parametric tests and our non-parametric tests. Chapter 6 focused on a lot of our non-parametric tests. This week we're looking at correlation. If we're using Pearson R, that would be considered a parametric test. And in order to use Pearson R, as we're about to do in a few minutes, there are certain assumptions that your data must meet, and there's a certain, so we can consider this kind of like a pre-test checklist that we must meet. And if we're wanting to run a correlation, we need to make sure that our data are normal, our data are linear, and we don't have any problems with homoscedasticity. And we are going to look at each of these, each criteria in just a minute. Each criterion in just a minute. If you look under additional resources, there's going to be a Word document called Parametric Testing Assumptions. You can pull this up, and this is going to list all of the each criterion and how to figure out whether your data meet each criterion. So the two variables involved in this, the 2 continuous variables. Now, another assumption that you must meet for correlation or for a correlation analysis is that your data must be continuous. So we have 2 variables here, homework and GPA. They are both continuous. So we're looking at criterion 1, with normality. And to inspect for normality, we can create histograms for our variables, just like what we did when, in the chapter of descriptive statistics. So, we can do this. We need to create a separate histogram for mark and one for GPA. And there's an option to do this all at the same time. So, let us go to Analyze, go to Descriptive Statistics, and then Frequencies. And I see that my variables were already there. If I go, your variables should look like this. So I'm actually going to move them here. And so I'm going to move them from the left window to the right window. I'm going to click on Charts, and I want to click on Histograms. And I also want to click on this checkbox here to show a normal curve on the histogram. And when I click on Continue, I will then click on OK. And now I have a histogram created for homework and again for GPA. Now remember, when you are examining a histogram, you need to decide if your histogram has a symmetrical bell shape. And so notice that the curves here, notice where our data fall So this bar is a little tall right here, but overall, both distributions are fairly normal. They are reasonably symmetrical. There's no notable skewing here, and so the criteria of normality is satisfied here. Now, our next two assumptions that we need to test for is linearity and homoscedasticity, but these are both graphical. We actually need our scatter plots in order to determine if they meet these assumptions. And so we're going to go ahead and we're going to examine those two criteria in our results section once we get our scatter plots and our results. So let's go ahead and test for a correlation. So let's go ahead back to our data set, and we are going to create a scatter plot in order to run a correlation. So let's go ahead and run a correlation analysis. We can go to Analyze, click on Correlate, and then bivariate, because we are examining two variables. And your two variables should have started in the left window. Mine are already moved, so I just literally, they were in the left window, moved them over to the right window. And it shows that I'm going to use my Pearson correlation coefficient, and I'm going to click OK. This gives me my output for correlations. Notice it gives me my p-value, it tells me my n, my sample size, and my Pearson correlation coefficient. So we also need a regression line, though. We also need a regression line in order to examine the linearity of our data. So let's look on, so let's go back. We're going to put this output off to the side just for a second. Let's go back to our data set. Let's go back to the main menu. We're going to go to Graphs and Chart Builder, and we want to create a scatter plot, and I see that mine is already here. Let me see if I can erase this so I go back and do it together with you guys. Let's see. I'm going to run through the steps with you. If it's still there, I'll just go ahead and tell you what these steps are. So, okay. So, first thing I want to do, I'm going to double click on a simple scatter plot. And then I can drag homework to the x-axis, and then GPA to the y-axis, and then I can click on OK and give me my scatter plot for my data. Now, in order to get my regression line, place your cursor on the actual scatter plot and double click. And this little icon right here is actually going to be it says add fit line at total. If you click on this, it applies our regression line. So we're going to close it. When we close this window here, it's actually going to stay in our output. So let's see, and you can clearly see that our data are actually pretty linear. And remember, if you remember, our coefficient, our correlation coefficient was 0.8 something. So that's a pretty strong positive correlation, and you can verify that by viewing it on the scatter plot as well. And so now that we have our scatter plot, we can now finalize our final two pretest criteria, our linearity and homoscedasticity. So the simplest way, if you're looking at to explain this regression line without presenting the formula, is to think of it as an average straight line pathway through the cloud of points based on their positions. So just as the descriptive statistics provides a summary of a single variable, the regression line provides a graphical summary of two variables, our homework and our GPA. So again, we already covered our criterion 1, normality of the distribution of the variables, homework and GPA. Remember, we had our histograms that had normal curves. Now let's assess the remaining two criteria, linearity and homoscedasticity. So the points on the scatter plot should form a relatively straight line. Hence, you can see right here our points do fall along this straight line fairly well. It should take about a middle of the road path through the cloud of points. So if the overall shape of the points departs from some other shapes that is not conducive to a straight line, then that would constitute a violation of the linearity assumption. So if we just have plots, just outliers here and there, just all over the place, it's not around our regression line, this would violate linearity. But in this case, we have met our linearity assumption. So our data are normal, our data are linear. Now let's see, let's determine homoscedasticity. So homoscedasticity, it pertains to the density of the points along the regression line. So how dense are the points along the regression line? The criterion of homoscedasticity is satisfied when the cloud of points is densest in the middle and it tapers off at the ends. So think of it kind of like your histogram, where most of your data will fall in the middle of your histogram and fewer taper off on the ends. Okay? So it's following the same notion as the shape of the histogram. The majority of the values gather around the mean. So it looks like our assumptions are met. Our data are normal, our data are linear, and our assumption of homoscedasticity is also met. So that means because all three assumptions are met, it is okay to proceed with a Pearson's R correlation. We can use our parametric test for correlations. Now let's go back and look at our output here, our correlations output. Now notice that we have a positive correlation, R is 0.881, positive correlation between homework and GPA, and we have a p-value of 0.00. Now our p-value is not just 0, it's actually just a number that's really small. It's 0.00000, probably 357, etc. But for this case, it's 0.000. So when we record our findings, we would say p is less than 0.001. So since the p-value is less than an alpha of 0.05, we would say that there is a statistically significant correlation between homework hours and GPA. So this positive correlation pertains to the positive slope of the regression line. So if I say that there is a significant correlation, that means that there is some type of relationship. There is a significant relationship between these two variables. We cannot say that there is causation here. Remember, I said we cannot say. A correlation analysis does not say that one variable influences the other. I cannot say that homework hours causes, has an effect on GPA. We cannot say that with a correlation analysis. The only thing we can say is that homework and GPA, homework hours and GPA, there is a positive relationship between the two. So for this particular study, for these findings, if we had to summarize our findings, we can briefly state we were interested in discovering if there was a correlation between the number of hours of homework a student did in a week and his or her GPA for that week. Correlation analysis revealed a strong positive correlation between these two variables, R of 0.881, which was statistically significant. The p-value was less than 0.001, using an alpha level of 0.05. Because of this, we would reject our null hypothesis and our second alternative hypothesis, HO and H2, but we would not reject H1. So basically we are accepting our H1 hypothesis. Now if you don't remember, if you're wondering, okay, where's HO, H0, H1, H2, it's the very last slide of part 1 class lecture for this week. That's where I indicated the three hypotheses that we would have for this particular study, for our correlation study. So notice all I'm doing, I am basically telling, first I'm stating basically what we're interested in examining in this particular study, what variables are being examined. I am stating my findings here, my results in my correlation analysis. I'm giving the correlation coefficient. I'm stating the p-value, whether or not it's significant, and I'm telling you if which hypotheses we would reject and which one we would accept. Okay. This is the end of our class lecture for this week. I hope that you all have a better understanding of correlation analyses, and I'm hoping that between the class lecture and the resources for this week will help you with your homework. So we have 2 class lectures here. We have part 1 and part 2. You also have your parametric testing assumptions Word document that you can use that goes through the steps of going through the parametric testing as well. And you can also find the correlations example SPSS file and additional resources as well if you would like to practice that with that data file before you begin your homework.